We're on page 2 of your Math and Chemistry Stoichiometry note packet. There are 4 main types of reactions that we're going to be talking about. We're going to add a 5th to it eventually. And by the end of the year, you'll have well over 10. Our first is synthesis. Synthesis is 2 or more substances combined to form a new compound. 2 or more substances combine to form a new compound. So write that down. That's your definition. 2 or more substances combine to form a new compound. There's a general format that we have for all of these. The general format is A plus B yields AB. And that's just a generic formula. And we start with 2 separate things, and when they react with each other, they do combine to form a compound. A good example would be when 2 irons, and I'm going to give you a balanced equation here, combine with oxygen, and we make 2 iron oxides. So we make rust. Iron won't do it all by itself. Oxygen won't do it by itself. They do need to combine to make that iron 2 oxide. Our second kind is decomposition. It's a single compound, generally a single compound, undergoes a reaction that produces 2 or more simpler products. A single compound, now in this case we're starting with the compound, undergoes a reaction that produces 2 or more simpler products. Now it doesn't say that we're producing elements, but a lot of times you will see them as elements, and our general format is AB yields A plus B. And if you look at it, there's a very, very similar thing going on here between synthesis and decomposition. They're opposites. So let's take an example of, if we start with 2 molecules of water, and once again giving you a balanced equation, we're starting with that compound. It will produce 2 hydrogens, which is a gas, and 1 oxygen, also a gas. So we can take that water and we can split it. We're starting with a compound, and these are simpler because they are elemental. So those are 2 of them. I'm just going to slide this up. A single replacement is 1 element replaces another element. In a compound. Now for all of these you're going to reference table J, which we're going to spend a lot of time on. Table J. Our general formula is A, there's our single element, plus BY, and so 1 element replaces another element in a compound. And it's going to do a replacement, and now A is bonded to Y, and B is all by itself. It's sort of like A stole B's partner. A good example of this is we have 2 aluminums, and we've got 3 iron nitrates. And what happens is that aluminum kicks out the iron, and all of a sudden we've got 3 irons all by itself. And we are going to do something similar to this in lab on a small scale. And we have 2 aluminums that are bonded to those nitrates now. And like I said, I'm giving you balanced equations, that's why the coefficients are already there. Our last one on this sheet is a double replacement, where we have 2 ions of 2 compounds exchange places. Now sometimes you'll see them as ions, sometimes you will see them as written as a compound. We will go over that in depth in class. For this one, you're going to be looking at table F. So we've got 2 new tables for this unit. Our general formula is AX plus by yields ay plus bx. Notice how in this case our x and our y changed places. Sometimes it will be the a and the b. It does not matter what order we write them in, as in I could have written by plus ax or ax plus by. It has to do more with what it's bonded to. Our main example for this is going to be iron sulfide plus 2 hydrochloric acids is going to give us iron chloride plus hydrogen sulfide. Okay, and that's it for now.